A geological scar carved deep into the Norwegian landscape. The Sognefjord plunges to an astonishing 1,300 meters. This chasm, wider and deeper than the English Channel itself, presents an insurmountable barrier. No bridge, no conventional tunnel dares to cross its immense expanse. For generations, Norway's vital coastal highway has been forced into a frustrating dance, stopping 7 times for ferry crossings. Each halt a delay, each passage a gamble. In the unforgiving grip of winter, these lifelines cease to function. Ferries cancel, leaving communities isolated, essential services unreachable. People miss critical hospital appointments. Children lose precious days of school. Lives are quite literally lost when ambulances face 3-hour detours, navigating around the fjord's impassable maw. This is Norway's most profound geographical challenge, a relentless impediment to its progress and the well-being of its citizens. The solution? Born from desperation and audacious the frigid surface of the fjord. Bridging this colossal waterway is an engineering impossibility. The widest section demands spans of 3 kilometers, dwarfing the world's longest suspension bridge by an entire kilometer. A traditional subsea tunnel, plunging 1,300 meters, would encounter rock pressures so immense they would crush any known machinery. So engineers confronted 3 stark questions. Can you bridge it? No. Can you tunnel under it? Impossible. Can you float a tunnel through it? No one had ever tried. Yet Norway chose the impossible one. Chief Engineer Ariana Minaretti, with the quiet conviction of a pioneer, affirms the floating tunnel is the only solution that actually works. The current system of 7 ferry crossings costs Norway billions annually in lost time, delayed freight, and failed emergency responses. The economic and human toll is staggering. This radical project promises to reclaim 10 precious hours from the 21-hour journey between Kristiansand and Trondheim, transforming it into a mere 4-hour drive. The concept itself is elegantly simple, yet its execution demands unprecedented ingenuity. 2 colossal concrete tubes, each a meter thick, will house the road. These tubes, naturally buoyant, will be held precisely at a depth of 30 meters by 2 opposing forces. Massive pontoon tubes will float on the surface, absorbing the fjord's wave energy during storms, while anchor cables stretch down into the abyss, tethering the structure to the seabed. The tunnel, suspended between these 2 forces, will be a marvel of balance. Inside, drivers will experience a normal tunnel. Outside, it will be an engineering spectacle, a silent, submerged artery defying the fjord's raw power. The construction method remains uncharted territory, an epic challenge that will push the boundaries of human innovation. But for Norway, the cost of inaction is too high, and the promise of connection too vital to ignore. For generations, the majestic fjords of Norway have stood as formidable, beautiful barriers. Their sheer glacial walls plunge into depths that defy conventional engineering, carving paths too vast for traditional bridges, too profound for submerged tunnels. These natural wonders, while breathtaking, have long severed communities, forcing arduous detours and unreliable ferry crossings. A fundamental challenge, deemed by many as insurmountable, persisted for centuries. This enduring problem, this constant disruption to daily life, was simply unacceptable in a modern world. What if the very water that created these impassable divides could become the medium for connection? A radical vision emerged. Not a bridge soaring above the waves, nor a tunnel burrowing through rock, but something entirely new. A structure designed to embrace the liquid environment, to become one with the fjord itself. It is a concept almost alien to our understanding of infrastructure. Too deep for a conventional tunnel, too wide for any practical bridge, this audacious solution floats. It exists in a hidden realm, suspended far beneath the surface, allowing the vast expanse of the fjord to remain entirely undisturbed above. The tranquil waters, reflecting the towering peaks, offer no hint of the monumental engineering marvel concealed 30 meters below. Imagine vessels, some as grand as 70 meters tall, gliding effortlessly across the fjord. Their passengers, gazing at the dramatic scenery, remain blissfully unaware of the silent, submerged highway passing directly beneath their keel. 30 meters down, where light barely penetrates, a concrete artery carries the flow of life, a secret passage known only to those who built it. They pass, never knowing the silent revolution beneath. The Sognefjord crossing, a name that will echo through engineering history, stretches for 3.7 kilometers. It is not just a single structure, but a pioneering blueprint for a series of 4 such crossings, each presenting its own unique, formidable challenge. Each tunnel will vary in depth, in length, in the specific currents it must defy. And none of them, not a single one, had ever been built before. This was a venture into the absolute unknown. The sheer logistics of such an undertaking are staggering. At 30 meters below the surface, fresh air does not simply arrive. It must be forced, continuously, relentlessly. Powerful fans hum without cease, a perpetual mechanical breath ensuring the survival of those within. Their operation is non-negotiable. They cannot, will not, ever stop. The construction begins on solid ground, a stark contrast to its final resting place. Massive, precast concrete sections, each a staggering 200 meters long, are meticulously crafted on land. These colossal tubes, with walls a full meter thick, reinforced with intricate webs of steel, take shape in conventional dry docks. It is a monumental task of formwork, rebar, and concrete, executed with precision. Yet the true test, the moment where engineering meets the abyss, only begins when these behemoths touch the water. A single waterproofing failure, a microscopic flaw at 30 meters depth, means catastrophic inundation. Water would surge, filling the entire tunnel in mere minutes. Every single centimeter of every joint, every surface, every seam must be absolutely, impeccably sealed. There is no margin for error. Each 200-meter section, a hollow concrete leviathan, is launched into the fjord with the delicate precision of a ship. Workers on barges, tethered by powerful cables, guide these massive structures, controlling their descent with an almost surgical grace. This launch, the very act of committing these tubes to the unforgiving embrace of the water, stands as the most dangerous, most nerve-wracking moment of the entire construction. A slight miscalculation, a wrong angle, and the entire section could sink, irrevocably lost. The engineering tolerance for this maneuver is measured not in meters, not even in centimeters, but in mere millimeters. Once precisely positioned, the colossal tube is ballasted. Internal tanks slowly fill with water, calibrated to perfection, gently lowering the structure to its exact, predetermined depth of 30 meters. Adjusting the water volume by the slightest degree allows for an astonishing level of control, guiding a 200-meter concrete mass with the finesse of a surgeon's scalpel, down to the centimeter. The ultimate challenge then unfolds, joining 2 of these immense sections, underwater at 30 meters depth, under the crushing pressure of the fjord. The connection must be instantly, absolutely watertight. Human divers working in the chilling darkness race against the clock, their time severely limited by decompression protocols. Every single connection, every bolt, every seal must be perfect. There are no second chances. Once the sections are securely joined, the tunnel finds its equilibrium. Massive pontoon structures are attached to the surface, providing buoyancy, while below, an intricate network of anchor cables descends into the abyssal depths. The tunnel, now a suspended artery, hangs in perfect balance between these forces, a testament to human ingenuity defying gravity and hydrodynamics. In the Sognefjord, these anchor cables plunge a staggering 1,000 meters, reaching depths far beyond human endurance. Divers cannot descend here. Instead, remotely operated vehicles, or ROVs, become the eyes and hands of the engineers. Piloted from the surface, these robotic emissaries navigate the crushing pressures and perpetual darkness to make the critical connections to the fjord floor. a realm that has never before been disturbed by human construction. The fjord itself is a living, breathing entity, with unseen currents constantly flowing, exerting immense, relentless pressure on the submerged structure. The anchor cables are not merely holding the tunnel in place, they are resisting this perpetual, moving force, designed to endure for eternity. Above, winter waves in the Norwegian fjords can swell to 4 meters, crashing against the surface pontoons with terrifying power. The tunnel, however, cannot yield. It cannot move even 10 centimeters. Every winter brings these colossal storms, a brutal test of nature's might against human will. Yet, 30 meters below the churning surface, the tunnel will not budge. It stands resolute, an immovable object against an irresistible force. This is not merely an engineering feat, it is a promise. A 100-year guarantee of unwavering stability. A testament to a future where connectivity triumphs over the most formidable natural barriers. While ferries may fail and mountain roads may close under the weight of winter's fury, this submerged passage will remain open, a lifeline. It is an elegant solution to an ancient problem, a silent marvel beneath the waves, ensuring that the majestic, once impassable fjords of Norway now connect rather than divide. The impossible made real, hidden in plain sight. The dream of a floating tunnel, once a distant vision, now takes tangible shape. This marvel of engineering, designed to defy the very elements it inhabits, will sit below the capricious weather, a silent guardian beneath the waves. It is built not to be closed, but to offer an unparalleled sanctuary. Its design envisions 2 colossal tubes, each a conduit for traffic, connected at precise intervals of every 250 meters. Should the unthinkable occur, an incident within one tube, drivers would find immediate refuge, evacuating seamlessly into the parallel passage. Pressurized shafts, meticulously engineered, would then guide them safely to the surface, away from any peril. Imagine a fire 30 meters beneath the surface. A terrifying prospect. Yet, within this design, a sophisticated suppression system activates in a mere 30 seconds, unleashing its power to quell the blaze. Simultaneously, an immense smoke extraction network, capable of moving 200 cubic meters of air every second, would purge the tunnel, ensuring breathable air and clear visibility for escape. This is not mere speculation. These are the parameters being meticulously crafted, tested, and refined. While the floating tunnel remains a complex blueprint, a testament to audacious ambition, another monumental undertaking is already carving its way through the very bedrock of Norway. Project Rogfast, a name whispered with awe among engineers, is a subterranean epic unfolding right now. Massive tunnel boring machines, or TBMs, relentlessly chew through solid rock, descending to an astonishing depth of 392 meters below sea level. These are the same skilled hands, the same dedicated minds, who will eventually ascend from the depths to construct the floating tunnel poised above them, a testament to their unwavering expertise. Deep within this subterranean labyrinth lies another unprecedented feat, an underwater roundabout, positioned at a dizzying 250 meters below the sea's surface. This will be the deepest road junction ever conceived, a swirling nexus of engineering brilliance nestled within a mountain beneath the crushing weight of a fjord. 10 million cubic meters of rock have been painstakingly removed, blasted and drilled away to forge this colossal space. Rogfast, a 27-kilometer dual carriageway plunging 392 meters deep beneath the fjord, is on track for completion in 2033. This is not a distant plan. It is a living, breathing construction site where crews are daily advancing 4 meters of tunnel 392 meters down. The floating tunnel, with its even greater complexities, will demand an even longer gestation. Rogfast is a testament to what is possible now, while the floating tunnels are still being meticulously engineered, their every curve and connection debated, refined, and reevaluated. The fjords themselves have stood sentinel for 10,000 years, carving Norway's identity, and the nation, in its wisdom, has cultivated a profound patience. The relentless sea, however, knows no patience. Waves will crash against the colossal pontoons of the floating tunnel, an incessant rhythm of 10 impacts every minute. Over a century, this translates to a staggering 5 billion individual assaults. There is no historical precedent for such an enduring structure. No X-sting. Countless simulations run, every conceivable scenario explored. Construction cannot begin until this exhaustive research yields definitive answers, until every variable is understood, every weakness mitigated. Norway, a land of ancient geological forces, also experiences earthquakes. Though rare, their reality demands unwavering resilience from any structure. The floating tunnel must be engineered to withstand a magnitude 5 tremor without a single leak, an unyielding fortress against the Earth's unpredictable might. The dangers also lurk above. A colossal ship losing control, its massive keel plunging through the water, could reach a depth of 15 meters. The tunnel, suspended 33 meters below the surface, offers a buffer, a margin of safety. Yet, the threat of a dragging anchor tearing through the seabed remains a persistent concern for the structure below. Concrete covers, robust and formidable, are designed to offer protection. But engineers readily admit that no perfect, infallible answer exists against every conceivable threat. The financial commitment alone is staggering. The Sognefjord crossing, just one segment of this ambitious vision, is projected to cost $25 billion. The entire program, an audacious transformation of Norway's coastal infrastructure, escalates to a colossal $40 billion. At its heart, the challenge is purely one of engineering, pushing the boundaries of human ingenuity. Parliament must grant its final approval, a crucial legislative hurdle. Construction, therefore, cannot possibly commence before the late 2020s, with completion potentially stretching into the 2040s. Across the globe, 12 nations watch Norway's pioneering research with bated breath. The United States, China, Italy, industrial giants and engineering powerhouses all await Norway to take the first audacious step. They are designing something truly without precedent, a structure for which no reference project exists, no historical data to draw upon, no safety net of past experience. They are, quite literally, writing the textbook as they go, charting unexplored territory in the realm of mega engineering. For millennia, the majestic fjords have been both Norway's beauty and its isolation. They have sculpted a unique culture, but also imposed immense logistical barriers. The floating tunnel promises to shatter this isolation, to offer a passage free from the whims of ferries, free from the tyranny of weather. For the first time in history, the agonizing wait for an ambulance, trapped by a ferry schedule in an emergency, a delay that can stretch up to 3 hours, will become a relic of the past. The tunnel will end that. A journey from Bergen to Stavanger, which today demands 5 hours and 30 minutes, will be dramatically transformed. The fjords, silent witnesses to 10,000 years of human endeavor, now face their greatest challenge: to be conquered, not by force, but by intellect. The floating tunnel is more than concrete and steel. It is a declaration of defiance against nature's barriers, a bold leap into a future where connection triumphs over isolation. It is Norway's indelible mark on the landscape of global innovation, a testament to unwavering vision and a profound commitment to pushing the very limits of what humanity can build. For generations, the majestic fjords of Norway have sculpted both the land and the lives of its people, creating breathtaking beauty alongside formidable barriers. Today, traversing the E39 highway, a journey from Kristiansand to Trondheim, demands a grueling 21 hours. It is a path punctuated by 7 ferry crossings, each a forced pause, a surrender to the elements, a severing of connection. This fragmented route, a lifeline for coastal communities, has long fostered economic isolation, stifling growth and limiting access to vital services. But a monumental shift is underway. Imagine that same journey transformed. Imagine a future where the E39, after its radical overhaul, allows passage in a mere 2 hours, or perhaps 2 hours and 45 minutes, depending on the final design. This isn't just an upgrade, it's a revolution in connectivity. The vision promises to shrink distances, allowing goods from once remote fjord communities to reach bustling European markets in a matter of hours, unlocking unprecedented economic potential. This audacious undertaking, projected to cost an astonishing $40 billion, is not merely an expense. It is an investment in the very fabric of a nation. It is an investment in a student's future, no longer condemned to 3 ferry crossings just to reach university in Bergen. Soon, that same student will drive a single, uninterrupted road, free from the whims of weather and the constraints of schedules. Norway's fjords, Scandinavia's most visited natural attraction, currently rely heavily on these very ferries, creating bottlenecks for the millions who seek their grandeur. The E39 project promises direct, seamless access, transforming the tourist experience and further boosting the local economy. But this isn't a project conceived for Norway alone. The world watches with bated breath. From the rugged coasts of Chile and New Zealand to the vast waterways of Canada and the deep lochs of Scotland, nations grapple with similar geographical impediments. Italy, with its stunning Lake Como and Lake Maggiore, has long dreamed of bypassing its watery divides, yet lacks the engineering blueprint. Norway is not just building a tunnel, it is forging a paradigm. It is proving that the seemingly impossible is, in fact, achievable. Italy and many others, even China, facing the immense challenges of the Three Gorges region, has its engineers studying Norway's methods directly, recognizing the profound implications of this pioneering work. The Scottish Highlands, scarred by lochs plunging deeper than 200 meters, possess 10 prime sites ready for similar solutions, once Norway proves the concept definitively. This is a testament to 2 decades of relentless research, a commitment measured in hundreds of millions of dollars poured into a technology that, until recently, existed only in the realm of theory. Norway, with meticulous foresight, is patenting every single solution it develops, from revolutionary anchor systems to groundbreaking pontoon designs and innovative joint connections. The world, undoubtedly, will license this intellectual property, cementing Norway's role as a global leader in civil engineering. The very idea of a submerged floating tunnel, patented in Britain as early as 1919, remained a distant dream for a century. Now, in 2025, it is being engineered into reality in Norway. 100 years between a visionary concept and tangible construction. South Korea has its own proposals, China its detailed studies, Italy its ideal locations. Yet, Norway leads this global race by a decade, propelled by sheer will and unwavering determination. This monumental effort will replace a familiar sight, the ferry, battling the elements in a Norwegian winter, a daily ritual across the fjords. It is a scene of stoic beauty, but also one of inherent limitations. Right now, in 2025, the Rogfast project, an immense undersea road tunnel, is already under construction, a precursor to the even bolder vision. Floating tunnel research continues at a feverish pace. Parliament has given its crucial approval. Securing the final funding is the next critical step. The Sognefjord, a stretch of water spanning 1.2 kilometers, is almost certainly destined to host the world's very first floating tunnel. While not the largest in scale, its significance as a proof of concept is immeasurable. In Oslo, engineers toil, designing something truly unprecedented. There are no textbooks for this, no previous failures to learn from, only the boundless frontier of human ingenuity. Parliamentary approval for the grander floating tunnel schemes is anticipated in the late 2020s, with the first major floating tunnel possibly opening by 2035. The colossal Sognefjord, the deepest and longest of Norway's fjords, might see its own submerged connection by 2045. Inside, the experience will be deceptively ordinary. 2 lanes, bright lights, the familiar hum of traffic, all 30 meters beneath the surface of the meant to human ambition. The captain of a ferry, navigating his vessel across the very waters that will one day cradle a concrete tube of cars, looks out at the expanse. He knows he will be retired by the time that tunnel opens, but his children, he imagines, will be among the first to drive through it. Their journey, once defined by the ferry's slow, rhythmic crossing, will be transformed into a seamless passage. a direct connection to a future their ancestors could only dream of. The Husufjorden, 1.2 kilometers, almost certainly the first. Not the biggest challenge, but the most profound. Long before the first foundation stone is laid, before even a single permit is officially stamped, the workforce is already in training. Because when the moment of approval arrives, the specialized teams must be ready. Not in weeks, not in months, but on that very day. This is the Sognefjord in winter, a landscape defined by relentless storms, by impenetrable ice, by the sheer unyielding force of nature. For a century, this waterway has defied conventional crossings, its depths a barrier. Yet the vision for this new tunnel demands it operates through all of it, for 100 years, uninterrupted. The concept itself has been extended, evolving from an idea first conceived around 1919, now slated for completion possibly by 2035. Today, a journey across these waters can consume 21 hours. After the E39 project is complete, that time will shrink dramatically to just 11 hours. Currently, 7 ferries navigate these treacherous passages. When the innovative floating tunnels finally open, that number will fall to 0. Norway isn't merely constructing a tunnel, it is embarking on a 10,000-year quest for invention, pushing the very boundaries of engineering. Beneath the surface, the fjord plunges to a staggering 1,300 meters. The tunnel, defying all intuition, will not rest on the seabed. Instead, it will float, 30 meters below the surface, suspended. Above it, an astonishing 1,270 meters of open water. Nothing but the void, held in check by massive pontoon sections and precisely calibrated anchor cables. Consider the family that relies on the ferry every single day. In winter, cancellations are frequent, forcing them on a 3-hour detour, a daily disruption that carves away at their lives. This tunnel promises to change everything. 400 meters of ancient granite soar above the water, while the fjord drops to its 1,300-meter abyss below. The tunnel will hover, 30 meters down, a silent, submerged marvel. Today, ferries still ply their routes. The fjord remains uncrossed by a direct link, but the designs are nearing completion. In the next 10 to 20 years, this entire reality will be transformed. A full century after a British engineer first patented the audacious concept of a floating tunnel, Norway is finally bringing it to life. The reason is starkly simple. They are done with the unpredictable tyranny of winter ferries. This monumental undertaking, projected to cost $47 billion, represents something never before achieved on this scale. It will span 4 fjords, forever altering the nation's infrastructure and setting a new global precedent. The question is no longer if such a feat is possible, but when it will redefine our understanding of what can be built.